So we're asked to find the antiderivative of z times secant squared z dz, which will make this an integration by parts. When we go to choose our u and our dv, we want to look for what's going to be easiest for us to calculate. What you should notice in this one is with the secant squared, we can find the derivative, but we know it's antiderivative, so that's probably going to be a good choice for our dv. So secant squared z dz. For our u, that leaves a z, which we like because when we calculate our dz, calculate our du, it's just dz. Our v is the antiderivative of secant squared z, which is tangent of z. And we're ready to put this back together in our uv minus the integral of v du form. So uv is z times tangent of z minus integral of v du. So we got tangent of z dz. Now that's the part that we have to take the antiderivative of, and once we have that, we'll be in good shape. So let's see how we take the antiderivative of tangent. So one way of doing it, if you don't have it, some people have it memorized and that's fine, but I want to show you how you find it. So that if we're doing this antiderivative, remember that tangent is sine of z over cosine of z dz. So now we're going to have a u sub, and I'm going to let u equal cosine of z, and then our du is negative sine z dz. So putting this together, we got to finish off our integral there. So z tangent of z is already done, minus, now here, this part here is going to be our du, except for the negative, but that'll just make that a positive. And then we end up with du over u, which the antiderivative of that is natural log. So we have z tangent of z plus natural log of the absolute value of u, but it's cosine of z. So I skipped a step in there, plus c, and there is our antiderivative.